Hello everyone, and welcome to this week's Cassandra Community webinar. My name is Christian Hasker with DataStax, and I am delighted to have with me this morning Eddie Satterley. Eddie has been a longtime supporter of Cassandra and the community, and currently is the CTO of Big Data and Analytics at CSC. Make sure to follow Eddie on Twitter and also friend him on LinkedIn as well. He is a highly networked person in the industry and a great person to know. So a little bit of housekeeping before I turn it over to Eddie to talk to us today about building Python apps on Cassandra. If you would like to ask us a question, please use the Q&A tab inside of WebEx. Type your question in there, and we will get through just as many of them as we can, depending on how much time we have at the end. So once again, use your Q&A tab inside of WebEx and ask us questions there. So Eddie, we have passed the ball to you, and you should be in control. Thank you very much for joining us today. Take it away.
Thanks. Okay. So, yeah, as you mentioned, I've been working with Cassandra for a long time, since .6 I put into production with my old team. I've recently joined CSC to run their big data and analytics, and right now, a lot of that's very focused on legacy technology integrations with the two, but we're doing a lot of fun things with Cassandra now too, so there'll be more coming out of that. The app specifically I'm going to talk about today is, first I'm going to talk about the driver and how it works and what's there, but the app itself that I'm going to talk to is an app that was built to do integrations between Splunk and Cassandra. There's an old version of the app that's still out there in GitHub today that uses the old approach with a lot more painful things, and the new version has been built with a Cassandra Python driver. It's being tested right now and will be updated in the GitHub soon. It's also in the slide deck. So we can jump right in. So the first thing is, where is the driver? With all the DataStax drivers, there's the github.com site with DataStax, Python-driver. Tyler, who wrote this, at least most of it, is on here. Basically, if you walk through this, you have all the dependencies. It has the normal README files and everything all tied to it. So if you want to use it, it's actually pretty easy. There's even a link directly to the API documentation on there, which I'll also have in the slides, in a couple slides. But that will help you with some sample code, some perf testing code, and some other things that have already been written to make it easier for you to get started. So I'm going to jump right into kind of the key features and why I cared a lot, why I'm moving stuff over to this new driver versus using some of the old approaches that were available with the old CQL shell stuff and the PyCos drivers. So obviously, a lot of people are moving over to the CQL interface rather than using the older approach with the thrift side. Some people still use thrift, so my app even supports the thrift side as well if you need to do it that way. But since a lot of people are moving over to CQL, I wanted to move it over. A lot of people are still in a mixed mode of CQL2 and CQL3, so we needed something that would be able to handle that and be able to do queries and pull metadata no matter what it is. So that's it built into this by default with a configuration parameter, which is really nice because I can call something with CQL2, and if it doesn't work, I can call it with CQL3 and see if it works and handle all of that within the Python code in a really quick and easy way rather than having to call different methods. So one of the key features that's out here from the configuration perspective is setting up connection pooling and doing automatic node discovery. The old way was really painful. I had to put in a set of nodes, and then I needed Python to basically do all the smart things to decide what node to connect to. We had to use a pseudo-random algorithm, which, as we all know, doesn't work particularly well. And causes a few little issues with nodes getting hit far too often. If a node went away, Python just ignored it going forward, so it would never come back. So a lot of the features in here with the connection pooling, you can just put in a couple of seed nodes In the case of the cluster configuration, my cluster, which mirrors this, has 5 nodes in it running AWS. I've got .1 through .5. I just seed it with .1 and .2. When the connection happens, it actually goes out and auto-discovers the additional nodes in the cluster and spreads out the connections across those. That is super, super valuable when you need to go to something that, well, when you need to do a whole bunch of queries and distribute them in a large-scale environment. And a lot of the ways that you do the queries, especially like the Splunk app, when you're issuing a search, it goes out and hits all the nodes, and if you write a poorly defined search, you could be there a very long time and would be pounding on a single node, and depending on whether you use multi-thread or multi-process, which I'll talk about a little later, it can really make a huge performance impact even on that one node. Now, Cassandra will deal with it, but there's no reason to do it. This actually does all of the node discovery for you and does it all in the set. So this little snippet of code here is directly off of the README from the actual driver itself. We basically just set up a cluster, put the nodes in, connect to it, issue some kind of query, do something with it in the ... and then close it out. So, like I said, you have the 2 nodes in there, and it'll auto-discover the rest. So 3, 4, and 5 will be available. They will be queried as well. You just didn't have to put them in the configuration setting. The only reason I put 1 and 2 in there is to have 2 just in case one of them's offline. So some of the key features that I use and I think are really, really valuable that didn't exist before. There's some extended cluster attributes. In this particular app I'm talking about, I'm not using the key space one, but in an app that I've helped someone work on for their particular use case and doing some advanced analytics and pulling some stuff into R Python and doing some work there, they want to restrict heavily the key space that can be connected to from the app. So they've set a default key space, and they do not allow people to get to where the code is executed from. They have a UI wrapped around it. So this one key space is the only thing that can be queried. You do not have to worry about people bouncing to other key spaces or doing anything against them. Since they can't touch the actual Python code itself, they don't have the ability to do anything creative about it. They use basically a gateway server that runs web services and built a little UI wrapper around it. But this allows their analysts who are allowed to see a key subset of data that lives in a specific key space to only be able to call that from within the code itself. So you've basically hard-coded a key space, and that's the only key space that will be workable. It's just the really quick version, just in case you don't know the Cassandra nomenclature. Key space is at the top level, which you can think of as like a database instance from a relational database space. Then you have column families under that, which relate to the relational database table types. So when you look at those, you're restricting it to basically, this would be equivalent in the SQL environment of restricting it to a particular database instance so that you can control who got to what from the application. You can also turn on a lot of other things from in there. There's, I think, about 60 or 70. You can look it up, but different configuration options. One that I use is the metrics enable. It controls metrics collection, whether it's on or off. The SSL option, so a lot of the environments that I work in, why it's not in my app is not in, by default turned on. A lot of the environments I work in, customers really want to use this option for in-transit between the client and the node communications so that you're doing encryption. As long as it's turned on the cluster side, you just turn this option on in your Python code and you're getting SSL encryption between the cluster node and the client node. Very, very important in certain compliance environments and certain network boundaries where people crossing, especially for public and private mixed information. Load balancing, this is by far and away my favorite feature that's in here. The default for that's around robin, but it can be configured. And load balancing, before, like I was mentioning earlier, there would be hotspots and nodes for queries. So a query would be issued, it would hit a particular set of nodes, and those nodes that were in the list would basically get hit frequently, and it started to see a pattern of that happening and getting a lot of load on a particular node set. So with this, without having to write a bunch of interesting things in Python to do it myself, it's already pre-built into the driver at the level of the driver to be able to handle the type of load balancing and to make sure that the load balancing works. Because, as I mentioned, the pseudo-random stuff is not the best thing to have to use to control that. Some of the other things, the default timeout, another thing that you have a lot of problems with is you can basically sit there thinking you're running a query that you're sure is going to return results, and if there's a mistake in it, or if the data is not there, or things have changed in the data model, you can be left hanging. You may not ever get a connection failure message back with the old way of doing it. This way you can set the timeout. It'll automatically detect the failure in that timeout range, and you'll immediately get a response back telling you that it timed out so that you can catch that error and let the client know that there was something wrong rather than just letting it sit there and run. A lot of times this is set pretty high. I mean, I set it to several minutes generally for my app configuration just to make sure that there's plenty of time to be able to let it respond if, in fact, it's overloaded for some reason, or you wrote a really horrible query, the equivalent of the select star query that you should never write, but lots of people do. So if you've done that kind of work, that way you at least get a timeout to know that that's the issue and you need to write a better query or format your query better, or make sure that the data even exists, because it's very easy to make a mistake writing a query, as I'm sure we all know. The row factory piece, so this is extremely important for like the Splunk specific app that was written, but it's important to a lot of the people that I talk to in the space to be able to figure out how the data is going to be returned, what the format's going to be from the result rows, so that you can write handlers to be able to do whatever it is you need to do with them, whether you're using them in R, or whether you're dumping into another data set, or whether you're visualizing them in your own app or the Splunk app, or however you're doing it. Making sure you know how they come back so that you can handle all of those kind of one-off situations that before the old approach, and if you look at the code that's on the GitHub now, you have to catch a whole ton of exceptions, and there's a few places where you just hope that it works. This will let you know exactly how the rows are being returned and in what the format is for those rows, so that you can handle them in an optimal way to be able to get them to whatever your analysis process is as quickly as possible. So obviously the options, returning as a tuple or a name tuple or a dict or an ordered dict. The old way, you had very limited choices on how to make this return, and you had to handle the fact that sometimes it didn't return them the way you'd like. I've run several thousand queries through this, and once this is set from the decoder side, every time I get the results in the right format and I can handle them, and I never ever throw exceptions, which makes me very happy. One of the customers that uses this version of the app right now is doing a lot of the testing for me on the Splunk connector app. They're doing about 35,000, I think it is, queries per day against the data set. They're doing analytics and merging that data with data and other sources, both the machine data stuff that's coming into Splunk, as well as pulling some stuff in from a relational database to do lookups. So if you're doing that many separate queries with basically the equivalent of a join to get all the data sets in, if you start seeing any kind of performance-related issues or issues with you missing records, it would highly impact their business process, the way their analysts are viewing the data. So it's super important for them to be able to make sure they know that every record is being processed. It's not being caught by the code and thrown out or as an exception, or that it's not being processed at all. And one of the other things that is great, especially for my particular use case, but again, another couple of customers that I know that are doing stuff with the driver, is being able to do the execute async. So you still have the execute command or method the same way you used to, There's an available execute async command here, which basically will let me go on and do other things while I'm waiting. It's very, very important when you're trying to do very large queries again, that you can actually run the query with the async command. You can basically create a response object, and then you go through and walk through that and go do different things, analytics, whatever it is you're doing with them, but you can process them as they come through. So you don't have to wait for the result sets and a blocking op to do it. However, if you want to force blocking, you can actually call the object and force blocking on it to a point. So you could say, execute this as async. I want to go do these 15 other things. Once I finish these 15, I will then connect to the object and force blocking to go ahead and wait until I get the last set of my results. So you may want to build somewhere to put them. You may want to look at the metadata that you've returned from a command and go build something else to move the data to. You may want to do, a number of different things, but those things can be done in the process while the query is actually being executed, whether it's a read or a write query, it doesn't matter. But while it's being executed, you can go do other things in your code and then come back. So also super important if you're doing multiprocessing approach to get better speeds and performance times. And there's a bunch of perf data that's stored in the GitHub side. There's a link to it. You can see all the perf data for the different ways you can do async and synchronous communication and the different configuration options to get better performance across the nodes. There's a bunch of other things I didn't call out. Like I said, I think there's 60 something that are in there. The ones that I mentioned are the ones that I've seen with the most value, either because of my app and the way that I implemented things in my app, or because of the fact that I've talked to customers and people, and I spent most of last year talking to about 160 different organizations that are in various forms of big data adoption, and talking to them about what they're doing, and a lot of them are doing some really interesting things. Python's kind of resurged as an interesting way to do things, especially with a lot of the analytics workloads. The R folks are doing stuff in R, and a lot of the new open source components around doing machine learning and advanced analytics. They're relying on Python for a lot of that. I think partially because Python's pretty good at it, but more importantly in most cases is because it's harder to find Java developers these days who can do a lot of the work at the Java drivers. So the Python side having equivalent functionality or even better functionality in some cases in the driver, and being able to use a skill set that is much less competitive in the market space to go do these things within an environment is really important. So again, DataStax github.io/python-driver. Index.html will take you to the main index, but the /API is where you're going to find most of the things you're going to want to do. And I will say it again, I mentioned it already, but if you want to do high throughput operations, multi-threading is interesting, multiprocessing is far better, but make sure, in case you're not a Python master and spent lots of time doing this, make sure that you understand the implications of object passing with multiprocessing, because it will bite you. There's even a comment, I think, in the documentation about object passing and multiprocessing, but go look it up, go Google it. It will make your life painful if you try to do multiprocessing and try to pass objects between calls. It will not go well for you. So do pay attention to those caveats and use multiprocessing. So how I use it, my GitHub site's on here, the Cassandra app. Unfortunately, it's still the .8 version, which relies on the old drivers, which will show you exactly what you don't want to have to do anymore. The .2 version will be, it's imminent. I am waiting on a couple of test results from a customer. I had to do a couple of updates to it recently, and they're doing some final testing, so I'm just waiting for them to get time to get back to me to make sure that everything was fixed and that we've got all the bugs out, because of the fact that this is going to hit production in most people's environments. I want to make sure that everything's fully tested and ready to go. I'll also make sure that I get it into the Splunk App Store as well once the version 2 is out. But this new approach, the code is gotten rid of about 40 or 50 lines of code for most of the scripts. Gotten rid of a whole bunch of the exception and corner case stuff because we can do the row factory setup. So with all those things, it's made it much better. It's much, much faster. I did not implement multiprocessing in there on purpose, but that's mostly because I am a little afraid of how someone might use it. But I would suggest if you're going to use this in a production environment and you want really high skill reads that you go implement the multiprocessing side. Not hard to find, as you mentioned, Twitter or LinkedIn, or just Google me and you can find my email address if you want it. It's not, I don't keep anything private. I have a public life for work, so it's very easy to find me, ping me. I can't promise I'll answer immediately, but I can send you the multiprocessing code that I've already written to do this. If you want it, you can play around with it. You can do it your way, but I won't be checking that into the GitHub site just because of what might happen. And I would definitely recommend building your own playground. So, grab VirtualBox and put a 3-node cluster even on your own MacBook. It works perfectly fine. I do it all the time. I have an external USB drive that's got all my VMs on it. I boot them up from VirtualBox, and I can do a 3-node cluster, and I can do perf testing, and I can go test everything. And it doesn't impact, the normal workloads I'm doing for development to build an app or whatever else, build an integration, do something custom. So I was just spin up your own thing, go play with it, look at all the various tools that are available for Python now. And like I said, it's getting very hard to find Java people to do a lot of this work. So where you can use other resources, and in a lot of cases they come out of places you wouldn't expect, like IT organizations. The business people are pulling them in, or the data warehouse people are pulling them in because they have the Python skills. They can do a lot of this stuff and not have to write a lot of Java code to make it work. I have a couple other apps that I'm working on that are not related to Splunk for this. I'm working on them for specific customers, but as soon as they're done and cleaned up and take all the stuff out that's going to relate back to a customer, I'll get this checked in on my GitHub as well. So there'll be a couple more examples. And if you Google again, there's a few examples out there already from other people who built interesting apps in the space. So with that, we can move to questions, and I can talk specifics.
Thank you, Eddie, very much indeed. So we do have some questions coming in, but just a reminder, if you would like to ask Eddie a question right now, please use the Q&A tab inside of WebEx. So we will get through as many questions as we can, Eddie. First one, Nitesh asks, once we install DataStax Enterprise or Cassandra, we get, or Python requires us to be able to run CQL. Do we need, or we want to, I think the question is, we want to run CQL. Do we need separate Python drivers to be installed?
Yeah, the Python driver, the DataStax Python driver I sent the link to, is not installed by default. So yes, you will have to install the driver separately, and there's a couple of dependencies on there, but they're pretty simple things. None of them are ones that you'll have to worry about security reviews and any of that stuff for. So yes, it has to be installed separately. It is a totally separate component and does not come with either the Cassandra or the DSE install.
Okay, great. Thank you very much. And next question, and Eddie, I don't know how much you know about Asynchronous from Netflix, but can you compare the Python, this one from Milind, can you compare the Python driver with Asynchronous from Netflix?
It's very different. I mean, Asynchronous is built for a lot of particular functionality to Netflix that a lot of people have adapted to do different things with. It's more of a heavyweight app that lives in front. The Python driver is strictly a driver layer with an API so that you can call directly. So it doesn't have nearly the functionality. It's not built for a lot of the advanced stuff that Asynchronous was built to handle. but it is just basically a low-level driver to let you use the Python API and call down to the driver and let the driver handle all of the complications and intricacies of connecting to a cluster. So they're very, very different. The Python drivers is a specific driver functionality just to give you basic control. Asynchronous is more of an application built on top to handle a lot more advanced functions. So that's my take.
Okay, great. So I'm not sure if this one is a question or just a statement, but maybe you can talk to it a little bit. Cluster shutdown is a scary command. Sure raises one's eyebrows. You want to talk a little bit about cluster shutdown?
Yeah, probably not the best named function, to be honest. Yeah, that's great feedback for Tyler to change it to something else. Really, all cluster.shutdown does is shut down all open connections to the cluster. So specifically, if you're doing multiprocessing or multi-threading, depending on what you're more comfortable with, if you want to close down all the sessions to that cluster all at once, no matter where they happen to be, calling cluster shutdown shuts down all cluster instance connections. It does not actually shut down the cluster, although I get how that's scary because that would scare me too. I've never thought about it because I just use it because I've been playing with it since it came out. But yes, that's probably not the most aptly named command. It should probably be called something else to keep from scaring people to death.
Yeah, yes, good note for Tyler there, Eddie. Maybe you can hit him up and just say,
yeah, I'll ping him.
Yeah, something less scary. Can I use a Python driver in a C++ applications? Maybe this is an opportunity to talk about some of the other drivers that are available, Eddie.
Well, so the quick answer to that is not now. That's one of the most requested features for the app, and I don't know if there's, I can ask Tyler, or we can ping Tyler and find out. It is one of the most requested features, though, and I know it's on the list of apps or extensions that are going to happen is to build the, I think it's still listed on the front page. I'm looking just to see if there's anything in the Jira. Yeah, it's listed as becoming next. The features to be added, C extensions for encoding and decoding messages. So it is coming. It is highly requested. I don't know when it's coming, and I don't see a Jira for it. So I couldn't tell you when it's going to happen, other than to ping Tyler and maybe follow up after this. So if you want to email me, I can follow up and find out from Tyler how far along that is. But I know it's highly requested, so being able to use the C extensions is definitely in the plan.
What is the best way to ping you, Eddie? Is it just hit you up on Twitter?
Yeah, you can direct message me on Twitter or just use eddie.satterley@gmail.com. Okay,
great. Sujit asks, how does the new driver work in a scenario where a failover occurs in the cluster?
Yeah, so it actually has all the failover stuff built into the driver, so it handles failovers for you. It will mark nodes dead, and then it will reconnect to nodes. It is in the API documentation. I'm trying to see where it's at. Cassandra policies. So if you look at the API documentation online and go into the Cassandra policies, the load balancing stuff, which I talked about, I didn't talk about the rest of it, but there's a capability to mark hosts up and down and then reconnecting to dead hosts. So all the auto recovery stuff is built into the driver itself. That's why when it reconnects the next time, it actually goes and interrogates the cluster again to find out what nodes are up. You can also set retry policies in groups. So there's a whole lot of advanced things I didn't talk about, unfortunately, but there's a lot of policies that you can set, and a lot of them are related to reconnecting to the dead host and the up-downs, and then making sure load balancing is working, and making sure that you auto-discover the nodes every time you make a new connection. So that's all built into the driver for you. You don't have to worry about it. It will just work. And I've had lots of failures. and I can verify that it actually works.
Okay, great. And this is a good question. So Pankaj is asking, can it be integrated with Python Django framework and be accessed through ORM?
Well, it can definitely work with Django. I don't know the answer on ORM. I haven't tried it, so I can't tell you. But I know absolutely that the front end that I helped the customer build is all Django based because they're a big Django user. So my guess is yes, but I can't say for sure that ORM works because I've never actually tried it. But it definitely works with Django. That is a front end that's been built. I will see if I can get the folks who wrote it to open the Django one and just push it out somewhere. They may or may not. They're challenged sometimes to be able to let code go out if it adds value for them. So, but I'll ask if they can. I'll, if you want to email me again and for follow up or, use direct message me on Twitter, I'm happy to see if I can get them to open up the code. And if not, I can give you some snippets of the stuff that I wrote for them to help them connect the Django side.
Okay, great. Here's a question that I will answer. So we get this question every time, and I should have addressed it up front. So every webinar we do is recorded and made available via Planet Cassandra. So this webinar today and all previous webinars are available there. This webinar, along with Eddie's slides, will be available. We usually try and turn things around very quickly, so within about 24 hours, we will post them to Planet Cassandra. Planet Cassandra, also a great resource, community resource, lots of information on drivers there, as well as use cases and getting started. And so if you're new to Cassandra, definitely check that out as a resource. So Eddie, another question related to the failover. Does it support data center level failover automatically, or does the application have to decide when to connect to remote data center if local nodes serving data go down?
Well, so it will discover the entire cluster. So the geodiverse piece would be discovered as part of the node count. It uses the distance to decide which ones to query first in the load balancing if you set it up that way. So there are policies to help you set it up correctly to make sure that you're hitting the local nodes first. But it will indeed, if a node that's local isn't available, it will take the further hop and go to the other nodes as long as you haven't forced it not to via the settings. And again, that's in the API documentation. It will tell you how to set that all up under, I believe that one's under cluster rather than under policies. I think that's under the cluster settings. But yeah, it's under cluster settings. But it does that automatically. So when it sets up the connection pool, it looks at the distance setting. So as long as that's all configured correctly in your cluster, it will go to the ones local first, but it will always cover the entire cluster. So worst case scenario, every local node goes down, you'd still be able to hit remote nodes.
Okay, great. And just a couple more questions here, Eddie. Is there a best practice for long-lived but intermittent connections from an application to a cluster, dealing with idle time, reconnection, for example?
I don't know that there's a set best practice anywhere. There may be, but I don't think I've seen a specific best practice anywhere. There's a lot of things that I just do because I know to do them, and there's a lot of things that you can find just by Googling it when you're setting something up of other people, because a lot of people in this community share very well. But I don't know of any place that I've actually seen a best practice documented for any of that, but like I said, I'm sure it's out there somewhere, and I'm sure there's lots of people with opinions on it. So you dump in that question somewhere, I'm sure you'll get an answer for a particular use case.
Okay, great. Okay, just looking through here. Okay, well, I think we've gone through all of these questions now. So, Eddie, thank you very, very much for joining us today. We have 2 upcoming webinars to remind everyone about. Boris Wolf from Comcast will be talking about some of the things he's been working on at the Comcast Silicon Valley Innovation Center, building a message bus on top of Cassandra. And then Aaron Morton and Patrick McFadden will be here on May 15th, and they will be talking about designing a Cassandra solution. Both of those webinars, great if you have experience of Cassandra, but also very accessible if you do not have prior Cassandra experience. And then if you want to continue your learning of Cassandra, make sure to take the free online Cassandra training. The URL is on the slide right now. And then do not forget to register, especially if you're in the Bay Area, but if you're not in the Bay Area, definitely worth flying in for. September 10th and 11th is the Cassandra Summit 2014, and you can find details about that on the DataStax website. If you would like to submit an abstract to speak at the summit, we have exactly 1 month left with the call for papers open. You can find that link on the datastax.com website as well. So Eddie, as always, it's a pleasure. Thank you so much for joining us, and thank you for your continued support of Cassandra.
Thank you very much.
Okay, we'll see you next time, Eddie. Thank you.